Today we're looking at notes T-2 inverses with composition. So on number 1, asked to find cosine of arctan of 4, how would you do that? So find this given this. Use the inside to label your triangle. So a couple of things you want to think about. You want to think about what is cosine and what is tangent. So remember that cosine is x over r. Okay, tangent is y over x. So this is like y over x, because 4 is like 4 over 1. So you have y, you have x based on this, but you don't have r. So you have x for cosine, but you don't have r. So you're going to use the same right triangle trig that we've been using to find out what r is. So okay, we know x is positive 1, so I'm going to start my triangle over here. So that's my starting point. X is positive 1, so just like you would plot a point, you go in the positive direction for x since it's positive 1. And from here, you go in the positive direction, so up 4. Okay, I know this isn't exact, but there you go. So, and then the angle that we're talking about is the angle created here when I connect. So that's my theta. Okay, so x is 1, y is 4. They're both positive. That's why I went right and up and not right and down or left. Okay, now I don't know r. So again, we're going to use that right triangle trig. So x squared plus y squared equals r squared. So that would be 1 squared plus 4 squared equals r squared. 1 squared is 1, 4 squared is 16, so 1 plus 16 is 17, so 17 equals r squared. Of course I want r and not r squared, so I'm going to square root both sides. Okay, the square root of 17 will remain the square root of 17, equals the absolute value of r. So then plus or minus square root of 17 equals r. However, you already know r is a distance, it cannot be negative. So therefore, r is just positive square root of 17. So square root of 17. All right, so now we have all we need to find cosine. So cosine of theta is equal to, as we already stated, x over r. So our x value is 1, and our r value is square root of 17. Okay, you know that you cannot leave that radical in the denominator, so rationalize, multiply by square root of 17 over square root of 17, and you get square root of 17 over 17. So final answer here, cosine of arctan of 4 is equal to square root of 17 over 17. Final answer. Okay, so let's look at number 2. On number 2, you're asked to find tangent of arccosine of 4/11. So I'm going to label a couple of things. Tangent is y over x. Okay, cosine is x over r. All right, so we have x, we have r, we don't know y. Here's the deal on this problem. Okay, so x is positive 4, r is positive 11. What we need to determine our answer is y. Well, how the heck do we know if y is going to be positive or negative? So you are going to use, come over here, draw a line. We are going to use our arc restrictions from before. So use arc restrictions when you need help with signs. So why are we doing this on this problem and we didn't on the last? Well, on the last problem, we had to find out what r was. We didn't need help. We knew r was always going to be positive. Okay, so we didn't need help with signs. On this one, we know x, we know r, we don't know y. Okay, we need help because we don't know if y is supposed to be positive or negative. On this, r is always positive. We didn't have an issue. On this, we don't know what y is, positive or negative. So use your arccosine restrictions. Remember from before that your restrictions for your outputs for arccosine go from 0 to pi. So that right there tells us exactly what we need to know. This tells us that y, what we don't have, must be positive, right? Of course, because look, all our y values in this restricted area are positive. So that tells us y must be positive. Okay, so now let's use our right triangle trig. So our starting point, just make it here. Our x value is positive, so we'll go to the right 4. We don't know what y is, but we do know it's positive, so that means we'll go up instead of down. We don't know what it is, but we know it's positive. And then the angle we're talking about is the angle created here. We do know our r value is positive 11. Okay, so let's use our trig. So x squared, 4 squared plus y squared equals 11 squared. So 16 plus y squared equals 121. Of course, you want to move that 16 over. So it's going to be y squared equals 121 minus 16. So y squared equals 105. So square root each side. You get the absolute value of y equals square root of 105. And so y equals plus or minus square root of 105. But our restriction tells us y is positive, so positive square root of 105. So we're going to use that, of course, to help us find tan. Remember here, the top, what you're finding for your final answer is the outside. So here we need tangent of theta is equal to, tangent is y over x. Okay. So y is square root of 105, x is 4. So our final answer is square root of 105 over 4 for our final answer. Make sure that 5's all the way in the radical. Okay, let's do one more. So number 3. So cosine, notice I'm going to use brackets here, cosecant inverse of negative square root of 10 over 3. That's why I used brackets, because I needed parentheses and I didn't want double parentheses. So let's label some things cosecant first. Cosecant is, remember that cosecant of theta is equal to 1 over sine of theta. Okay, so if sine is y over r, cosecant is r over y. So r over y. Cosine is x over r. Okay, so now we have r, we have y, we don't know x. We have r, we don't know x. So this is kind of labeled funny because that negative looks like it belongs to the r, but you and I both know that can't be true, so the negative must belong to the y. Okay, so we don't know if x is positive or negative, so we need to use our restrictions. So come off to the side and let's talk. So we don't have a restriction for cosecant inverse, but we do have a restriction for sine inverse. So you use the same restrictions as its reciprocal function. Okay, so same restrictions as the reciprocal function. So let's think about sine restrictions. Sine inverse restrictions. So sine inverse restrictions will be from negative pi over 2 to positive pi over 2. So that right there tells us exactly what we need to know. Tells us, remember what we don't know. We don't know x. So this clearly tells us that x must be positive. Look at the restrictions. All my x values here will be positive. So it tells us x must be positive. Okay, so let's see where that leads us. So now we need to do our right triangle trig. Let's label our right triangle. So y is negative. Remember that negative can't belong to the r. It's got to belong to the y. So we're going to start here. And of course, when we plot a point or when we draw a triangle, we don't talk about y first. We talk about x first. We know x is positive, so that means we're going to go right instead of left. X is positive, so we go right. Since y is negative, we're going to go down. Y is negative 3. We don't know what x is, so I'm going to leave that blank. Talking about the angle created here. And our r value is square root of 10. Okay, so x squared, don't know what x is, plus y squared when we have a negative value. Of course, we're going to put parentheses around. Y squared equals r squared, and same with radicals. You're going to put parentheses around r squared. So x squared plus 9 equals 10. We're going to move that 9 over. So it's going to be x squared equals 1, right? 10 minus 9 is 1. So then square root each side. Absolute value of x equals, square root of 1 is 1. So x equals plus or minus 1. However, since x must be positive, okay, there we go, label that. So now we have here final cosine of theta equals x over r. So x is 1, r is square root of 10. So again, of course, we must rationalize, you know, proper notation here. So square root of 10 over 10. So final answer, cosine of cosecant inverse of negative square root of 10 over 3 is square root of 10 over 10.